Welcome to Are You Ready to Garden? Hello everyone, my name is Bill Hlubik. I'm with Rutgers Cooperative Extension of Middlesex County. I am the agricultural agent for Middlesex County and a professor at Rutgers. Our team brings experts together from Rutgers University and the New Jersey Agricultural Experiment Station, as well as other horticultural experts throughout the state and local farmers willing to share their expertise with our listeners.
And as you know, the New Jersey Ag Experiment Station is an outreach arm of Rutgers, the state university. So our information is dispersed throughout the entire state of New Jersey.
Tonight, I'm going to be talking about soil testing amendments and preparation for healthy plants in your garden. Really, we're going to talk about the gamut of the proper way to take soil samples. We're going to talk about some amendments that are good to use and those that you should avoid to prevent problems in your garden. So we have quite a bit to cover tonight. We are going to cover why soil testing is so important. We're going to give you step-by-step soil testing procedures to get accurate results. We're going to go over why what soil amendments are good to use and those that we should avoid and why we should avoid those. The proper use of compost within our gardens and landscapes, why you should avoid some bagged soils because of some contaminants that may be in those, tips for tilling the soil to prevent problems, and we're going to talk a little bit about potting mixes, and I even have some formulas at the end of how you can create some of your own potting mixes. Okay, let's get started. This is a picture of our family farm, the Hlubik farm. This is our irrigation pond, and always protecting the soils that we have with making sure that we have grass buffers to prevent soil erosion. Also protects the water surrounding those ponds so that we're not washing soil or excess nutrients or anything into our irrigation system. So the same thing is true for our waterways too. We want to make sure we're protecting those, and we don't want soil to wash away because soil erosion is a very big problem in the US. So one of the things we do on the farm is we always utilize many different types of cover crops, and then we work those cover crops into the soil on our farm to really help improve those soils by building organic matter and putting that carbon that's needed back into that soil for those beneficial microbes. And that's what really leads to a healthy soil. We have to constantly replenish soils if we want them to stay healthy. The same thing goes with our garden soil and even the soil that we have where we have our turf grass. We got to make sure that we are recycling grass clippings and we're top dressing whenever we can with some organic materials that we'll talk about in a bit. And even in tough, difficult places like Mount Washington, where there's almost no soil, we see plants growing that have adapted, and here, in this case, some grasses that have adapted to these cold conditions, these very windy conditions. So plants can adapt to different conditions. So it's knowing what you can grow within a specific environment. So it's the right plant, right place. And plants are adapted to that soil environment that's there. So that's very important, and that's what we're going to focus on today. So in order for a tree or shrub or any plant to stay healthy, it needs access to nutrients, it needs access to sunlight, it needs oxygen to be able to go to the roots, it needs oxygen and CO2 exchange. So in order for many of our plants to properly get nutrients, to properly photosynthesize, we need to have a balance. And we need to have a balance that's specific to that plant. And this natural balance is much easier in native environments like wooded areas where we're recycling those leaves and all that organic matter right back to the soil. It provides those nutrients, it helps to build the soil. So we have to constantly build our more unnatural soils within our landscape setting. And even in areas where we're growing vegetable gardens, we have to replenish so that that energy cycle can continue and those plants can continue to grow healthy. And we need to make sure that that soil has adequate drainage so we're getting oxygen to the roots. we have CO2 exchange, and we have beneficial microbes in the soil that are able to survive and do well under the conditions within our landscape or in any container that we're growing in. So proper management of soils is really critical to help reduce plant stress, which then can reduce disease problems and can protect the local environment, so we don't have to use as much of the fertilizers and pesticides. If we're properly amending soils, we can actually have healthier plants with less inputs of fertilizers and pesticides. So the soil really is the foundation for a healthy landscape. So what is soil? Soil is that natural body on the surface of the earth where plants grow. We're going to talk about topsoils versus subsoils. And soil is mainly made up of minerals such as sand, silt, clay in varying proportions. But there's also many living organisms within that system. And those living organisms, those bacteria and fungi and actinomycetes, all these organisms are extremely important in order to keep our plants healthy, to cycle those nutrients that are in the ground so that the plants then will be able to utilize any fertilizers that we add to the soil. So one of the things that, why is soil testing important? Well, soil testing is extremely important for all gardeners. And we're going to talk about the best ways to do that today. It's important that we adjust the soil pH or soil acidity, and we're going to talk about that in a little bit, to match the needs of the specific plants that we are growing, to allow for proper nutrient uptake and the health of specific types of microorganisms that are actually going to convert those nutrients into a usable form that the plants can take up. So if we don't adjust the pH of soils, we could be adding fertilizers and the plant can't take up the fertilizer, and it can actually be in a nutrient deficiency if the pH is too low or too high, hence why we need to take a soil test. If we take a proper soil test, we can save money on nutrients, we can prevent deficiency problems, toxicities that could harm the plant, and even direct damage to the root systems. And we can protect the environment because we're not adding excess nutrients. We're following our soil test recommendations and providing the exact amount of nutrients that we need to feed those plants and adjusting the pH so that those plants are able to properly take up those nutrients. So if we look at a soil profile, we look at the organic or O horizon, which is usually in the top couple inches of soil where it's the highest. And the A horizon is the most active area where we have the most amount of organic matter and microorganisms and macroorganisms that are tunneling through that soil, exchanging nutrients, making nutrients more available. And that's the concentration area of most of our roots in that top 0 to 10 to sometimes 12 inches or more. In some places, the topsoil could be a foot deep. In other places, it could be 2 to 3 feet deep. It really depends on where you're at in the United States. It varies even quite a bit within New Jersey in terms of whether, it's 6 to 12 inches deep or 10 inches or 20 inches. Depends on where you are in the state of New Jersey. So this upper layer is called the topsoil, and that's the most productive. And the reason we don't want to lose that topsoil is because when that washes away or is eroded, it can take thousands of years to reform topsoil. And if you're left with subsoil, you have your work cut out for you in order to try to get that soil back into condition so that you can grow plants. As we go further down beyond this subsoil area, so as we get into the subsoil, it's more compact. We're going to start to see below that area the parent material or bedrock from where the soil was formed. Unless you're in a sedimentary area where you had sedimentary deposits along a lake or a stream or other waterways. So the parent material is that underlying type of rock, which was over years of weathering, broke up and combined with microorganisms formed the type of soil that you have on your location. So the basic physical characteristics of soil is that you have this mineral component, which is about half of the soil, Then you have the organic component, which is usually less than 1% in most of our soils, but that can go up to 2% or even higher depending on where you are and how much organics you're adding back into that system. And then the rest is balanced out with water and oxygen, carbon dioxide, and other assorted gases. You can't talk about soils without talking about the soil triangle. And the soil triangle is just something that shows you that as the percent of clay or percent of silt or sand changes within a soil, that dictates the textural classes of soil. So based on their percentages, you can have a high percentage of clay, so you're going to have a pure clay. And where you have a mixture of sand, silt, and clay, we start to get into loams like clay loam, sandy loam, or silt loams. And the loams are really some of the best soils for us because they have all three particles of sand, silt, and clay, as you'll see in a minute. So that provides porosity and nutrient retention, allows water to pass through, and those soils, and we can emulate some of those conditions of those ideal soils by some of the amendments and some of the practices that we use. So that's how the soils lab, when they do an analysis of your soil, they actually sieve out the amount of clay particles versus sand versus silt, and that's how they tell you exactly what your classification is. It's important to know the classification because the classification of your soil dictates how much lime we need to add to adjust the pH at a certain level based on the physical characteristics and the chemical characteristics of that soil. So this is very important for us to know. And the relative size of soil particulates is very important to understand that sand is a much larger particle, up to 2 millimeters. Silt can go down to 0.002 millimeters, and clay as small as 0.002, and even beyond that can even go smaller than that. So clay particles, that's why they stick together and can clump together, because the size is incredibly small. So by seeing this, the amount of sand, silt, and clay, you'll know that if you have different sized particles, of course, you have greater porosity within that system. And here's a quick way to tell what type of soil you have by doing the feel method. And using the soil textural feel method, you can simply take your soil, wetten that soil a little bit, and if you can form a ribbon on that soil, and the longer that ribbon is able to form, then we know we've got a lot of clay within that soil. If we get a very short ribbon, then maybe we have more silt in there or more sand. And if it feels very greasy to the touch, then that can mean that we've got more of the silt-based ingredients in there. So very rough is going to be sand, or the largest particle size. Slick and greasy when wet is going to be clay. Smooth when dry is going to be silt. So if we try to form that ribbon and it falls apart completely and we can't form a ribbon, it's more likely going to be mostly sand. And as it stays together longer and longer, that's going to be a clay-based materials. So that's a simple test that you can do within your landscape setting to determine the approximate amount of sand, silt, and clay within your soil. And when we have this combination of sand, silt, and clay, and we have that loam type soil, that's really where we have, as we mentioned before, the best porosity and the best conditions to really grow our plants, because they need that oxygen transformation and to keep the microorganisms healthy as well within that system. And whether it's the heavy soils of Hunterdon County, New Jersey, or the lighter soils of Cumberland County, they typically all will need a certain level of improvement over time, whether that's adding organic matter or utilizing cover crops to help improve those soils. And here we're growing, as we grow many of our crops, on raised beds so that we can control the moisture. And we're going to talk about how you can set up raised beds within your landscape by just pulling the soil in from the sides and then adding some organics instead of bringing a lot of outside topsoil in. because it's important to, in many cases, just to improve the soils you have and create raised beds so that you can control moisture and decrease disease problems. And you'll have a much better crop of anything you're growing, and you'll have healthier plants if you used raised beds. So just within a teaspoon of good garden soil, you can have 100 million or even way beyond that in terms of beneficial bacteria, and over 800 to 1,000 feet of fungal threads. And these are beneficial fungi and bacteria that are critical to the health of your plants and critical to the recycling of nutrients within that system. And then when we do our soil, take our soil tests, we want to go down into that A horizon. So we're going to go down anywhere from 6 to 8 to 10 inches when we take our soil samples. So that's important to understand how to take those samples. Okay, so let's go over soil testing, because this is why we're here and this is very important. So if there's an area that we designate as the front lawn or an area that's been treated differently over the years, that's going to be our soil test 1 area. So let's just say the front lawn is being treated all the same, and we don't see differences in the past when we've done digging in those areas. Then we're going to treat that as area 1 because it has the same type of plants. We've put down the same types of fertilizers and amendments in those areas. So we're going to test in anywhere from 10 to 15 different spots within that area in a randomized fashion. We're going to use a trowel or one of these handy soil testers that I have here, and we're going to show you a video in a second here of how we do that. And by taking those samples 8 to 10 inches deep, that's going to be where the majority of roots are. And by taking the 10 to 15 samples throughout the entire front lawn, putting those in a bucket and mixing those up, we're going to get a better representation of the soil within that area. We're going to show you a short video that explains exactly what I'm talking about. Okay, here you see that I'm scraping off a little bit of the organic matter. So I'm going down into the topsoil about 8 to 10 inches, as you can see there. And this is a soil sample probe. You can get these online for about $100, but you can just use a trowel as well. So I took off a little bit of organic matter on the top. I'll go around to about 15 areas throughout the front lawn. I can also just use the trowel. And here I have to make a couple attempts to get down into that soil so that I can get down 8 to 10 inches. So I'll take a sliver from there, and then I'll go down even just a little bit deeper. And then that will represent, and I'll do that 15 times over that area that I'm calling my front lawn and put that in the bucket. Then I'll mix all of those samples together with the trowel. And what that's doing is providing a homogeneous mixture and providing me a better representative sample. Here I am pouring the soil out onto, you can use anything, whether you have a tarp or a lid, and you're just simply going to dry the soil out in the sun before you put it in the bag to send it off to the lab. And you need to do that. You need to dry the sample out, take any stones out of there, and then you need to put about 2 cups of that soil into the bag that's going to go back to the soil testing lab. So you need to take those randomized samples, dry them out really well, put them back in the bag. If we don't dry them out, we're not going to get a representative sample. And you can see here that soil sample depth is very important, because if we don't get to the right depth level of where the roots are going to go, we're not going to get a good representation of how to adjust that soil within that A horizon, which is extremely important. So here's a diagram of a landscape, and we're looking at different areas. Maybe the front lawn, it's been treated the same. Maybe a vegetable garden area that we need to take a separate sample from. So in the vegetable garden area, we would take 10 to 15 samples of that area, and that would represent area 2. We would mark that on the bag, so that would go in as a totally different sample into the lab. We may have a separate rose bed. That area or flower beds would be treated differently. And then if we have ericaceous or acid-loving plants in a bed, and we've been keeping that pH lower, we need to take a separate sample for that bed. as well. And even your front lawn and back lawn may be totally different in terms of the way they're cared for, or you may see differences in the soil structure when you do the sampling. So in that case, you need to take separate samples wherever the soil changes or has been managed differently. So in this case, they're going to require 4 different soil samples, and they're going to mark those when they go in. And they'll get those results back, and they'll get those tests run. Typically, I'll run tests every 3 or 4 years and send them off either to the Rutgers lab or A&L or one of their reputable labs to give us results back on pH and nutrients. And we'll provide more information on that in just a moment. Any questions there from anyone, Angela?
Sure do. One question is wood ash beneficial for the lawn and garden?
Wood ash is beneficial. What I typically do with wood ash is I put it in my compost pile. You can add it, especially if you have ericaceous plants, you can add that around those plants. It's not going to hurt anything, but I typically will put it in my compost pile and then mix it in just to add the potassium and a little bit of phosphorus in there as well.
And you just spoke about taking soil samples for different beds. So if you have a vegetable garden where you're planting, say, cabbages and melons, and another bed where you're maybe planting blueberries, you would want to test those beds separately, correct?
Correct, right. If you have a very large garden and you have different types of plants, especially blueberries where you're keeping the pH lower, and in many cases with blueberries, you'd be adding more organic matter into those areas to compensate if you can't bring the pH down low enough. Yes, you would test each one of those areas separately. Wherever there's a change in management or there's a major change in the needs of those plants in terms of what they require, even where you have changes in sunlight, where you have shade-loving plants, the conditions there are going to be slightly different than they are in some of the full sun areas where you may have lawns and other plants.
And then generally speaking, how much can you adjust your soil per year? I know it really does depend on what you're growing and what the soil pH is, but if you really need to bring, say you have a very acidic soil and you need to bring that pH up, how much can you adjust for in a given season?
Well, it's so first you take the soil test so that you know where you're at, and when the results come back from the laboratory, that's why your first samples really should go to a lab like the Rutgers Soils Lab or a university lab in general, because they're going to give you more accurate results. From that, they're going to tell you if you need lime to bring the pH up to the proper range, or if you need sulfur to bring the pH down, they're going to tell you the exact amount to adjust. If it's an excessive amount, the soil test results themselves, when they come back, they're going to say, look, you're going to need to do this in stages. So they may say, put so many pounds down right now, and then wait a month or so, put some more of this material down, mix it in with the soil. If you're really in need of adjusting pH in a somewhat quick manner, then one thing that you can do, and one trick that growers and gardeners will do, is add more organic matter like compost or peat moss. Because what that can do is, by adding these organic substrates, they can actually very quickly adjust the ability of those plants to adapt, especially good quality compost, to that area. So if you're looking for a quick fix, and then over the long run, you're trying to adjust slowly to bring that pH where it needs to be for that plant, start off by using good quality completed compost, and then start to add the amendments based on those soil test results.
And then in a no-till system, how far down do you sample soil?
In a no-till system, you're going to do the same thing. You're going to go down 8 to 10 inches because you're still going to where the root zone is. In a no-till established system, your roots are still have the depth that they typically would. And in some cases, if you're really doing a fantastic job of doing no-till, you're actually eventually going to have even more depth because you're not going to have that plow layer or that hard pan that normally occurs. So you'll still get down 8 to 10 inches. Okay, so one thing, make sure you break up those cores, put those in a clean bucket, as we said before, dry those samples down, and then you're going to submit 2 cups of those samples to the laboratory. And the reason that we have to dry the samples down, we can't leave them in the bags wet, is because they will continue to react if we don't dry them out. And that will mess up our final results of our soil test. So it's very important that you do that step, is to dry those samples down. And then make sure you fill out the forms that come with the soil sample kit to let them know what you're planting in that area, whether it's a new seeding or an established planting. Is it a vegetable garden? What types of vegetables are you growing? And then send that sample and the questionnaire off to the laboratory, and you should get results back in anywhere from 1 to 2 weeks. Within that soil testing procedure, make sure you remove any stones or roots or other types of large organic materials, and make sure you air dry that sample before you send it off to the laboratory. And when you get your results back, it'll look something like this. We tried to blank out some of the names, and actually this is a little bit older sample, but you're going to get results back on your phosphorus, potassium, magnesium, calcium levels, and then you're going to get micronutrients as well, such as zinc, copper, manganese, boron, and iron. And part of that is these are critical nutrients. You're not going to get nitrogen back, because nitrogen is really going to be dependent on soil temperature, moisture, and also depends on the type of crop you're growing. And you'll also receive a pH indicator. So it'll tell you your current pH, and on the back of that form, it's going to tell you whether you need to use lime to bring the pH up or whether you need to use sulfur. It's going to tell you how much to use. It's also going to give you an indication of the type of fertilizer or the basic formulation of fertilizer that you need to use in order to have healthy plants through that season. So you really do need that soil test back, because it's like having a GPS system. It's going to tell you where you need to go based on your current conditions. And without this, it's really hard to have a successful garden or landscape. So soil testing is absolutely necessary as one of the first things that you do. And farmers are very cognizant of this. Farmers do soil testing every year because they know that if their pH is off, they're really wasting their money on fertilizer or lime or other amendments, and thus they've properly adjusted that pH, because that pH or soil acidity helps those bacteria and other organisms convert those nutrients into a usable form that the plants can use. Otherwise, they're not able to take those nutrients up, and you can actually see nutrient deficiencies even though you're adding nutrients. So here's the soil testing lab you can get a hold of, and we're going to post all of this afterwards, so that if you need, but if you want to write this down, you can. When you log onto the soil testing lab at the New Jersey Ag Experiment Station, there's a lot of information on there. There's fact sheets. We even have some of our videos on soil testing on there that you can watch. You can also call your local county cooperative extension office, and they can provide soil test kits for you, and you can get the soil test kits online as well. So this can be done on the internet, and there's a lot of good information at our NJAES website. So make sure you jump on there to take a look at all the information that we provide. And those soil tests, the basic fertility test is $20, and that's for your basic macro and micronutrients, pH, and that will provide you with a lot of great information as a start. There are other tests available, such as the soil plants suitability test, which will test nutrients, pH. It'll give you a soluble salt level that we're going to talk about a little bit later today. It'll also give you the organic matter, which is really important to know whether or not you're really low in organic matter. If your organic matter is lower than 1%, we got to make sure that we're adding organics to really have healthy soil and healthy microorganisms. It'll also give you the soil textural class, which is really important for you to know in the future as well. And you can also have a more intense topsoil evaluation, that will give you a lot of different recommendations about the specifics of sand, silt, and clay, soil textural class, and the a lot more detailed information, and that's $90. So for $20, you can do the basic soil test, and that's really what most people need to do. You can also test for lead, or if you suspect, if you're living near a highway or where there were old buildings where lead paint was used. Yeah, I believe the lead test is about $18 or $20 from the soils lab, and that will give you an idea as to whether or not you need to grow your vegetables or leafy vegetables in other areas, or create raised beds for growing those vegetables, because you don't want to grow in an area where you've got heavy metal contamination. So the soil test comes back, gives us that pH or soil acidity reading, gives us calcium, magnesium levels. The nitrogen, as I said, nitrogen is not really based on the soil test, but based on the needs of your crop. For example, on 1,000 square foot of lawn, you're probably going to need anywhere from 1 to 3 pounds of nitrogen, actual nitrogen per 1,000 square foot. And that's based on the needs of many of our turf grass varieties. But that will change too on the management practices. If we have clover in the lawn, if we recycle grass clippings, we'll need a lot less fertilizer. And in some cases, after the lawn is established, we may not even need to add any additional fertilizer past that point. But we will get important phosphorus, potassium, and micronutrient levels that will be provided by that soil test. And if any one of those nutrients is not at the proper level, so the difference between a macro and a micronutrient is just the amount that the plant uses, but they're all very important. Hlubik's law just simply states that if any one of the macro or micronutrients are deficient, we're going to see deficiency symptoms typically on the plant, either a physical symptom or lack of growth, or lack of vigor of that plant. So it's important that we take the soil test so that we know what's going on. So now you can see the importance of that. And we were talking about pH, just to try to wrap your head around that. pH can vary from 0 to 14, and right in the middle is pure water or milk is at about a pH of 7. And then as we go down into the lower numbers, it becomes more acidic, like natural rain is usually somewhere between 5, and 6. Beer and coffee are somewhere a little above the pH of 4. Vinegar's at about a pH of 3. Lemon juice 2, and battery acid is below 1. And then as we increase, baking soda is up around 8. Milk of magnesia and bleach is up around 12. So you can see the range of pH. So we want, for most of our plants, we want that pH to be between about 6 and 7 for the majority of our plants. But ericaceous plants or acid-loving plants actually like it below pH of 6. So we need to know what type of plants we're growing in order to properly adjust that soil. So for most of our plants, we're going to want them within that 6 to 7 range in order for them to stay healthy, in order for the pH to be where it needs to be for the beneficial microbes to convert nutrients. We want to keep that pH in the proper zone. And pH will affect nutrient availability. So this is a chart, and you see at the bottom, it goes from 4 to 9. And as there's rapid or major fluctuations in pH to either very high or very low, we can see that the availability of nutrients can decrease or increase or become even toxic at certain levels when the pH is not adjusted properly. So hence why we need to adjust that pH. So availability of nutrients, even the toxicity of aluminum can be a problem in certain types of soil, where aluminum can actually cause direct toxicity to the roots. The microorganisms we're very concerned about, because if we wipe out all the beneficial microbes within our soil, that wreaks havoc on our plants, because then they cannot grow properly because they have a symbiotic relationship with a lot of beneficial microorganisms. So those missing nutrients or excess nutrients can really impact plant health. Liming is really done based on soil test. And you can use pelletized limestone, which I would recommend, because If you use the powdered or pulverized limestone, you're going to be wearing it. It's going to be blowing all over the place. But the pelletized material, you can calibrate a little bit easier, and it will spread and be dispersed a lot easier with your drop spreaders or spin spreaders. And you want to test every 2 or 3 years for pH to make sure that you've got it adjusted exactly where those plants need it. If you need to lower the pH, if you have acid-loving plants, so what would acid-loving plants be? Rhododendrons and azaleas and hollies and certain types of pines really like the acid. So elemental sulfur, iron sulfate, aluminum sulfate, acid-based fertilizers. You can use organic materials such as pine needles or peat moss. They will actually help to lower the pH in those areas as well, and can modify pH. That's why it's good to keep your pine needles actually around the pines, because they're creating that ideal pH, acidic pH for those pines in that area. So some people like to haul them away, but it's actually a good thing to have them recycled right back for those pines to utilize. So relative deficiency levels, usually there's, if a plant is deficient, we may see symptoms, or we may just see decreases in yield. But when we optimize the amount of nutrients and the pH, we're going to maximize our yield, maximize the health of the plant, and prevent or decrease stress problems on that plant. On the other end of the spectrum, if we have too high of levels of any one nutrient, in other words, if you add extra fertilizer, that's not a good thing. And we're going to go into that in a little more detail later. But what will actually happen is you can have decreased growth. You can have salt toxicity within those areas, and you can have direct toxicity to those roots and the soil, where the plants have a very difficult time taking up water and taking up nutrients, even though the nutrients are there, because we're doing direct damage. So, you have to balance the amount of nutrients. So you have to make sure you're adding your nutrients based on your soil test. Now, sometimes if our soil test results come back and they say that we are low in magnesium, then we need to add dolomitic limestone. And dolomitic limestone simply contains the magnesium, and that will come back on our soil test to tell us that the soil test itself from the lab will say use some dolomitic limestone because you are deficient in magnesium. And magnesium is extremely important for plant health and the plant's system to be able to defend itself from pathogens. So we want to make sure, and magnesium is used in many different processes, phytoprocesses within the plant. So, and then regular calcium carbonate is limestone, and that will actually, it will tell you how much limestone, if you need to add just plain limestone to the soil. And you don't want to add more than you need. You want to just add what the soil test is telling you. Some people also use gypsum or calcium sulfate. They use that to, if they've got compacted soils, it can actually help to condition the soil. Gypsum is actually a rock, and it's an interesting rock, and it's like limestone, occurs naturally in many parts of the world. And even back during Benjamin Franklin, he was actually introduced the use of gypsum in this country, where they had some pretty horrendous soils where it was very difficult to work those soils. And at that time, the raw gypsum they called land plaster, and they used it to help break up soils and make it more easily tillable. But you have to be careful in terms of how much you add. Make sure you follow recommendations based on your soil test and based on recommendations from the ag experiment stations. There's a lot of great fact sheets about creating raised beds, and this is one of them, fact sheet 1328, soil for raised beds. We're going to talk a little bit about it right now. When you're creating raised beds, if you can use the soil, it is actually in place right now and not have to bring in a lot of outside soil, that's really the best way to go. So when we're creating raised beds on the farm or in a lot of community gardens, what we'll do is we'll work up all the soil with a rototiller, and then we'll bring the soil in from the sides of those areas to create our raised beds. And then we'll add some organics like well-rotted compost or peat moss or other types of well-rotted organic materials to help fluff up those beds to create the raised beds. And some beds will use plastic to lay over them, or we can build wood around them to actually create and keep that raised bed structure in place. So when you're doing that, it's best to use the soil that you have on hand and not bring in a lot of bagged topsoils, and we'll talk about that in a moment. So using your native soil is always a good first choice. There's also another fact sheet that's very good that just talks about topsoil suitable for landscape use. So what it goes through is basically, this is Dr. Joe Heckman put this on our website, and it's great information about some of the things you can look for when taking an overall look at the topsoil that you have. And then we'll talk about some ways in a few minutes here where we can amend those soils to really kind of bring out the best in our landscape setting. So the reason we want to avoid some topsoils is because if that topsoil has an unusual odor to it, if it smells like ammonia, or it has other peculiar smells to it, there is a possibility that it could have biosolids or sewage sludge in that, and we don't want to use that in areas where we're growing food crops. So you want to be careful. You want to look at the origin of the product and be careful about what you're adding to areas where you are going to grow food. I stay away from many of the bagged topsoils, and bagged topsoil is much different than growing medium and sterilized potting mix. We're going to talk about sterilized potting mix is fine to use, but these things that are called all-purpose topsoils, you got to be careful and read the label in terms of what they're putting in these products, because they can have a whole wide range of different components. And what I found is that some of these all-purpose topsoils stay wet too long, depending on the ingredients, and can cause actually more problems, can cause more harm than good in some cases. So you got to be careful about what you're adding. You've got to test the ingredients, make sure that wherever you're getting your topsoil from, that there's some type of testing done so you know what it contains if it doesn't give you much information on the label. And then potting mixes are a whole different animal. So many of the times we're using sterilized potting mixes to grow plants in pots, and many people will grow their tomatoes and peppers and many of their vegetables in pots. And usually what we're looking for in those mixes is we want a relatively light mix so we can move the pot around, but it has to be porous enough for oxygen for the root systems, and it has to have proper drainage so that we're not accumulating too much water around the roots. So then we don't have problems with oxygen deprivation and the dying of those root systems, and then also other types of water mold fungi coming in and killing those plants. But we also want those potting mixes to retain water and nutrients. So we want some organic matter in there in order to be able to maintain the health of those plants. So quality mixes that are out there really should be low in what we're calling soluble salts, with a pH of about 5 to 6.5. And a simple porosity test that you can do with these mixes is just simply add 2 cups of water to 1 quart of the dry mix in a container, and after a few minutes you should be able to drain off about 1 cup of water. Or to test for drainage and porosity, fill a 6-inch pot with mix and tapping lightly on the container while doing it to incorporate it in. And then you should be able to pour 1 quart of water through the pot, and the water should filter through in less than a minute. So that's giving you just a basic overview that you need this porosity, you need water flow, but you need it to maintain some of the moisture, but not all of it, because we want to make sure we're getting oxygen, nutrients, but we're retaining some moisture and retaining some nutrients. So just a simple rule of thumb. And we, on farms, we buy Pro Mix and other types of potting soils that are out there. You will see many of the Miracle Grow potting mixes, and the sterilized potting mixes are fine for starting plants, and you don't have to worry about those mixes containing any of those harmful compounds. And typically we use sterilized potting soil that are made primarily of peat moss, vermiculite, and perlite. And what they do is when we're starting plants, and you can get them in much smaller bags than this, of course, and you would start your plants in those, and some of them even contain fertilizer, starter fertilizers. But these are sterile mixes that when you're starting your tomatoes and peppers and eggplants and many of your plants that are sensitive, you'll get a good start without having damping off or the destruction of those plants in that setting in the greenhouse. So it's very important to start off with a good sterilized potting mix or potting soil. So that's different than bagged soil. So just understanding that difference. So here you see us using it within our greenhouse right now, where we've got tomato plants going, where we're using that mix of peat moss, vermiculite, and perlite, as well as some other ingredients in there. We put in there to keep the plants healthy, some nutrients. And these transplants are going to develop fine if they're in that system and we're not over watering. So watering lightly, but keeping the mix moist, that's really going to keep these plants at optimal growth. And those mixes usually have a proper pH. They usually come anywhere between a 5.9 to like a 6.3. It depends on what the mix is, but it's rated optimal basically for these transplants. And we don't want to over fertilize these transplants at that time, because by putting too much fertilizer down, we increase the electrical conductivity and the salt concentration, and we can actually do more harm than good, and we can actually kill off these young seedlings that are extremely sensitive to high salt concentration. One thing that we can use is fertilize with fish emulsion or soluble complete fertilizers. The fish emulsion, you may want to stay away from that inside your house because it has quite the odor to it. But there are many different organic options of fertilizers you can use. Many of the organic fertilizers and soil amendments contain the words OMRI, Organic Materials Research Institute. So if you're looking to provide organic-based substrates into your soil, use the OMRI labeled materials on those. So one thing that we can do to prevent seedling diseases early stage is we can use materials like root guard. One of the things that we worked on back in graduate school many years ago, which is simply a combination of different beneficial microbes like Trichoderma. These are beneficial fungi that exist in the soil. When we mix those into our potting mixes, they can actually protect our plants from damping off. So that would be a good thing to use. You can actually see beneficial fungi like this root guard that you can use even within your home greenhouse setting. And make sure you're using sterilized potting mix and you're not over watering, and you're getting plenty of air circulation in those areas where you're starting your plants. This is what Trichoderma looks like. This is what we worked with in the lab many years ago. So this is actually beneficial, and here you can actually see it under the microscope attacking some of the harmful organisms that are in the soil. So by adding root guard with this Trichoderma species in there, it's actually protecting our plants from some of these harmful fungi. So how do you make your own grow mix? Well, one thing you can do, if you want to mix for foliage plants, you can mix 2 parts peat, 1 part perlite, and 1 part of coarse sand. Or you can go with 1 part peat, 1 part pine bark, and 1 part coarse sand mix. So these are just some suggested ratios of what you can use. And some people will even throw in some of their compost materials. If the compost has been broken down completely, they'll replace the peat portion of that with the completed compost that's been broken down. So you could be 1 part compost from your compost pile. So that's one way to go. As long as the plants are established, you wouldn't want to use some of these materials when you're starting plants from seed. You would want to use a sterilized potting mix when you're starting from seed. But for your established foliage plants and transplants, you can do this. And then for seedlings that are already up, you could use a mixture of 2 parts compost, 2 parts peat moss, and 1 part vermiculite. We say pre-wet because you would want to make sure that the moisture was into the vermiculite when you first started, and also kind of mixed in with the peats, because otherwise it repels the water and will actually prevent that absorption. And then you just need to make sure that you keep the seedlings moist, but not overly wet in this mix that you're creating. Now, this is for seedlings after they're established, when you're spotting them after they've already come up, and then you're spotting them out into individual trays. You wouldn't want to do this for starting your seeds in the very beginning when they're coming up, because we want to prevent damping off. And then a soil-based mix, a little bit heavier, but can be used in a lot of different situations, where we can use 1/3 compost, 1/3 topsoil, and 1/3 sand. And we could use that in some pots if we wanted to lighten them up a little bit, or in any area where we're growing plants and we want to try to provide ideal conditions for those plants in that setting. This could be a good mix. And then we would still want to make sure before we added anything to those soils that we did that soil test way back in the beginning. One thing we look at when we're looking at different mixes is the electrical conductivity, and you can have that tested, but what it basically tells us if the salt levels are too high within a medium. If salt levels are too high within your growing medium, then what will happen is salts can do direct damage. You see, if we have very low levels, the plants may be starved of nutrients because they're not getting enough fertilizers. And we use electrical conductivity a lot when we're doing aeroponics and hydroponics, because we want to make sure that we're adjusting the pH in those areas. So we want those levels at moderate ranges of 0.51 to 1.25. And when you get your results back from the lab, if you ask them for electrical conductivity or EC results, they're going to tell you whether or not those results are within the acceptable ranges. And if they're not, they're going to tell you what to do to bring those areas back into safe areas of salt conditions for those plants. Also, we want to be careful not to work soils when the soils are wet. We want to do tillage coming up when the soils have dried out a little bit, because when we work wet soil, it really compacts the soil. We want to use lightweight equipment whenever possible, because if we're driving back and forth with heavy equipment, that will compact the soil. We want to minimize the number of passes that we do with the tillage machine if we can. In some areas, you can do no-till after you've had plants established for a while and you've had plenty of cover crops in there. But in some cases, we may need to go in and warm up heavier soils by doing tillage so that we can actually go out and get our plants started. And then we can work in organic matter, which could be compost or peat moss. And the trick here is to use anywhere from 2 to 3 inches of a good organic compost and mix that into the top 8 to 10 inches of soil. And we can use the same thing with peat moss. We can use, the big bales of peat moss, spread those around, mix those into the soil. When it's relatively dry, it can be just a little bit moist, but you don't want it soaking wet. And then by mixing that in, that's going to create an ideal growing environment for those plants. And then we can continue adding organics by using cover crops, spacing out the crops properly. We can even use straw in between that will help us control some of the weeds, but will also provide some organic matter that's going to break down over time and add valuable organics to the soil. You just don't want to get straw down in where the plant is growing, because it hasn't been composted, and that can actually pull nitrogen away from that actively growing plant. But well-rotted compost can be used, and peat moss can be used, and other types of organics that have been well-rotted that don't contain heavy metals can be used in those areas. We can also turn to local soils maps to get a lot of information. If you go to the Web Soil Survey, You'll see there's a ton of information on there that talks about the soils exactly where you live. Farmers use these local soil survey maps to find the types of soils that they have throughout their region. This is done by NRCS, Natural Resource Conservation Service, part of one of our partners in USDA. And you can also look at the erosion potential, whether or not it's the different classifications of the land, the depth of that topsoil, and there's a lot of great information. So as you toggle through when you go on that site, you'll actually put in your address, and I just put in the address of on the next one of our facility in South Brunswick. And when I put in that and toggle in, it actually shows me the entire park system there that we're in. This is the Earth Center. And then I can go in and designate the area that I want to determine the different soil types within that area, so that I can determine what types of soils I'm dealing with, the permeability of those soils. And that also helps me to determine how many soil tests I need to take in that area, because if we're doing larger scale soil testing, and if I have 3 or 4 different soil types on this area, and you can have different soil types even within your neighborhood, because soils can change depending on where you live. They can change from one block to the next block. So you can actually get an indicator of the soil types within your area. And then as you go on there and you ask for more detailed information on the soil designation, it will actually provide that information back that we have a Watchung silt loam in this area and a Woodstown loam, which is a very good soil, very productive soil, is 56% of that whole area of that map. So that means we've got excellent productive soils in that area. And then we can get even more detailed readouts of the information on each one of those areas. So you have access to this just by going on the National Soil Web Survey. And we can go back to that just to show you the, so this is the place where you go right here, websoilsurvey.sc.egov.usda.gov. And even if you just put in web soil survey from USDA, you're going to get to this spot. And then you just put your address in, as I mentioned, and it will actually take you in exactly, and you can zoom right in to your location and get a lot of really good information. There's also soil maps of New Jersey that provide detailed information on where soil changes throughout the state of New Jersey. And that means that there's different geological formations in the state that influence our soils throughout New Jersey and the productivity of those soils throughout the state. And to determine whether or not you're deficient in fertilizers or you have a nutrient imbalance or pH imbalance, look for light green leaves or yellow leaves. That could indicate a nitrogen deficiency. Leaves with dead spots can indicate that there's some type of disease. Smaller than normal leaves could be a macro or micronutrient deficiency, pH problem, lack of sunlight. And all of these things can be determined by, properly testing. And when we talk about complete fertilizers, when someone says add a complete fertilizer, when that comes back, it just means a fertilizer that contains N, P, and K. So that's nitrogen, phosphorus, and potassium. So those are the 3 letters on the fertilizer bag. The 32-0-10 means 32% nitrogen, 0% phosphorus, and 10% potassium. Why would we want to go with 0% phosphorus? Because our soil test came back from the lab and said we have adequate phosphorus, and we don't want to use it if we already have adequate phosphorus. By adding too much phosphorus, we can cause potential harm to the environment. So we want to make sure we're only adding what we need based on the initial soil test that we got back from the lab. There's a lot of natural ingredients that we can use to replace some fertilizers that we're typically used to. Backyard compost can be used to provide some nutrients, but it's typically very low in nitrogen and low in the macronutrients. So we typically will have to supplement a backyard compost with other types of organic fertilizers in order to have an adequate crop. Composted manures should be used the season before. Don't ever add fresh manures to a current season's growth. There are materials like green sand from South Jersey that can be used that help with exchange of nutrients, and other materials like kelp meal, blood meal, bone meal, alfalfa pellets. All these other materials are basically organic-based materials. Many of them are OMRI approved or Organic Material Research Institute approved. Do we have any questions out there, Angelo, before we?
Someone asked if there was a good substitute for compost if you don't have any.
Peat moss is a good substitute. And that's one of the few that you're going to be able to get your hands on quickly. So those are two of the main things that we turn to. And I like to create a lot of compost so that I don't have to deplete peat bogs. So if you're thinking environmentally, it's probably a good idea to create your own compost each year. But the one thing you can use as a substitution for compost is peat moss. Just don't over add it. You see here that we're even applying compost. We can apply it over lawns. We can spread anywhere from 1/4 to 1/8 of an inch of compost over lawns. We can put 2 or 3 inches of compost down in areas where we're starting a vegetable garden, and then just till it into the top of that area. And here I've built a screen out of 2x4s with a steel screen under that, and I just filter the compost through so that if there's any sticks or anything that hasn't been broken down, those will go into the wheelbarrow or the rotary spreader, and then I can throw whatever's not broken down back into the compost pile. You don't need a fancy gadget like this. You can even use your rotary spreader. Once you dry the material down and pass it through a simple sieve like this or screen, you can use your regular compost and even peat moss and spread it around easily. Any other questions on?
So other people were saying coconut coir is more sustainable.
It can be. And so that's one option that you can use. So coconut coir is another option because it lasts for a period of time. And one of the things we're trying to do with any of these additives is really provide a substrate and provide carbon and an area for those microorganisms to feed on. So coconut coir can be a very viable alternative as well.
And then
if it's within your price range.
Yeah. How about increasing some of your micronutrients like boron?
So there are fertilizers out there that have specific additives or micronutrients in them. So you can buy both organic and conventional fertilizers that contain mixtures of micronutrients. So if your soil test comes back and says you're low in micronutrients, your best bet is to add those nutrients in the form of a micronutrient solution. So other ways that we can improve micronutrients like boron, we can actually use food waste compost. Because if we use a good balanced food waste compost that has a mixture of many different types of vegetables and fruits within that food waste compost, there's going to be a whole host of those nutrients that are going to be in that food waste compost, and they're going to provide enough nutrients that we can substitute that well-rotted food waste compost for some of these other materials. So that's one way to achieve it.
Do you recommend any sources for sand to add to your soil?
Just check with some of your local retailers and wholesalers for what they would recommend as a good clean source of sand. And if they've run any tests, typically, most of these sand products, it's not that they have to test them on a regular basis, but you would have to look online and then just find one that's within your price range and a company that you can trust to ask around a little bit, because I can't as a university I can't recommend one company over another. So you would just get references from other people that have brought sand in large quantities, and then you could go with that particular company that gives you the price point that you want.
What is green sand used for specifically?
So green sand is from some of the mining that occurs in South Jersey. Green sand has the porosity benefits of sand, but it also can retain nutrients and moisture a little bit like heavier soils. So it's kind of the best of both worlds. Most of the green sand that's actually mined in New Jersey goes west because it's very expensive. So many people simply in this area don't want to pay the exorbitant cost for green sand, but you really don't need green sand. To be honest with you, you can do a lot of the same thing with inexpensive compost that you're creating and top dressing, recycling grass clippings. Anytime you can put organics back into your landscape by recycling those grass clippings back onto the lawn, by growing, actually incorporating and having clovers. Now, you might not like all weeds, but if you can withstand clovers, they add nitrogen and they add beneficial nutrients back into that system on lawns. And then cover crops can do the same thing. They can harvest and recycle nutrients into your vegetable gardens as well.
Worm castings. Do you recommend worm castings?
Yes, worm castings are amazing. And that's probably some of the best nutrients sources that we can use to help our house plants, to help our vegetable plants. You can even use it to make compost tea, which will help plants, help to boost the amount of microbes within those areas as well.
And real quick, do you want to discuss the difference between food waste compost and then I guess different from composting with food and leaves?
Okay, so leaf composting, because most of us have, well, many of us have a lot of trees, so we can take, and the bulk of what we're composting is high carbon based materials. When you start adding food waste in, you can do that even within your regular leaf pile. It's just a matter of mixing it more often, making sure that if odors start to occur, that we're adding enough dry materials in, enough carbon-based materials like leaves or shredded paper or other higher carbon materials. So you can have either straight leaf compost that you've turned, add a little tiny bit of soil to that to add those beneficial microbes. You don't have to, but it helps it break down a little bit faster. So that would be a straight leaf compost where you're just using leaves, turning it once a week or once a month in the wintertime, adding just enough moisture as a wrung out sponge. And by doing that, you're going to have compost in anywhere from 4 to 6 months, sometimes faster if you're chopping everything up with your mower. Food waste compost, if you can chop that up, you can also do a lot of food waste composting. And it's just a matter of chopping the ingredients up into smaller bits so that they will break down faster. And if it becomes too wet, putting some materials in to absorb some of that excess moisture, turning it more often, and you will get a high grade compost out of that as well. And a lot of our scraps that we throw, you just don't want to use bones and meat scraps in there because you're going to attract a lot of rodents.
And then one more question. Can hard water cause high soil pH?
Hard water continually used, really, I've rarely seen that as a major problem. You would have to irrigate a heck of a lot because a lot of the rainfall that's coming through is more on the acid side. So that's going to counterbalance any of the irrigation that we have in our outside plantings. So it really shouldn't be a problem overall. And if you have organic matter in those soils, you're going to be able to absorb some of that off balance that occurs there. So really, by adding compost and by adding peat moss a little bit to any of these situations, it really goes a long way to improving it. But as I'm saying here, when you're using finished compost and even peat moss, don't add too much. If it's surface mulch on a landscape, use 2 to 3 inches, whether it's compost or whether it's other types of mulches. Don't put it down too thickly because if you put it down too thick, it's going to cut off oxygen to those root systems. What it will do is it will protect those root systems from excessive temperatures, because one of the most sensitive parts on any plant, tree, shrub, vegetable, is the root system. If the temperatures climb too high or they get too cold, those plants go into a direct stress mode, which it takes a while for those plants to recover. So by having mulches around those trees and shrubs and vegetable plants, we can actually reduce the amount of stress to those plants, reduce the amount of disease problems, increase yield, and increase the overall health of those trees and shrubs. So some natural sources of fertilizer, composted animal manures, but we want to compost the manures first. Don't use them straight. We can use cover crops to improve soils like legumes, alfalfa, clover, and vetch. And typically in areas where we have pasture, we're always using a combination of legumes that naturally capture nitrogen. So it's actually a very good idea to have clover within your lawn. And you can add 1 to 2 ounces of clover in lawns. You just got to get used to it. And believe me, many lawns had clover in them up through the 70s. And then people, once they started using 2,4-D, they realized that all of a sudden they didn't want it in there, but it's actually beneficial as it helps to improve the soil. And manure can be a good thing. So here's composted cow manure. Can be great for soils to help build them up. And when you see something like this, what do you think this is? Disease? Or do you think this is a nutrient problem? This is actually blossom end rot. So it's from calcium deficiency, and it's caused because the tomato is not taking up enough moisture and enough calcium. And sometimes you'll see this on a certain flush of tomatoes where some will have this calcium end rot, and then the next growth of tomatoes coming in is fine because they're getting calcium and they're getting proper water uptake. So by using compost and by evening out our water schedule, we can, and as long as we have calcium in the soil, we shouldn't see this continue to occur in soils. And you can see the difference between healthy plants, green, phosphorus deficiency, sometimes we'll get red symptoms. Potassium and nitrogen will get yellowish leaves, and particularly with potassium, we'll see the outer leaves of plants start to show almost like a burnt-like appearance. And I think that's about it. Compaction's a real problem, so we do need to decompact areas whenever possible by doing core aeration. And that can cause a lot of poor growth in soils where we've got compaction. So by decompacting areas with core aeration, by tilling soils, by managing the pH, we can decrease stress on plants and actually have a much healthier plant and soil ecosystem. And otherwise, we'll have erosion and cracked soils, and I think that's it. And I want to thank all of our county freeholders in each one of our counties, but especially Middlesex County, Ron Rios, Ken Armwood, and all the freeholders for all the great work that they do to keep us in business, because we wouldn't be here without the partnership of Rutgers State University, the county governments, working together with the New Jersey Agricultural Experiment Station. And we want your success stories. So if in any way this information is helping you, please write back to us, because that helps to keep us on the air. And if you've been able to grow better crops this year, been able to start feeding your family with some fresh fruits and vegetables, we would like to hear those stories. Please contact us email us at mastergardeners@co.middlesex.nj.us. If you want to send us your information and your question to that same email, we will get to your questions with our Master Gardeners. Thank you very much for staying with us today. Hope you learned something new.